Yeah, as usual, we have this session to go through what has happened since last time and what's being worked on. And I hope, as usual, that you're helping me out with the status. Our primary focus since last time we met has been STM845 upstreaming. Yeah, we have managed to get a quite large bunch of the features in place. There is the regulators and clocks, the RPM stuff. Most of the clocks, or maybe all of the clocks, are supported upstream now. And then the order should be better here, but we got the pin control stuff, and we got a bunch of framework related things that we finally had to fix up because we couldn't just work around them. We got the DSPs and the modem up and running, and we have we had the GPIO controller for the wake up to wake the system out of sleep was merged, and there's work ongoing to how we tie that into the GPIO driver and and I think the GIC version is done.
Did we get the last bits to actually get booted on mainline? Is that queued for 420? 419 doesn't boot 845 now.
I think it boots, given that you do some def config, that you enable some configs. I don't know if I don't think we've gotten the def config updates yet.
Okay.
But boot meaning we get to console. We have regulators, clocks, and a few other things. We do not have storage wired up yet, and thereby a lot of the other features are not visible.
Okay, so maybe I was missing a def config option somewhere. I tried to boot it, it didn't work. So.
Yep, probably. So we did some work on the 600 series before we sort of dropped that or deprioritized it, and in 420 we finally got the last patches to get the 8998 or 835 to boot to a console. And the next steps there, it's quite a lot of reuse either from 820 or 845. So, but now we have the base in there as well. In the baseboard category, we have the PDR, which is it's a mechanism for so on some of the DSPs we run multiple functions. So like the modem and the Wi-Fi firmware runs on the same processor in different domains, like under a hypervisor in different domains. And PDR is the mechanism where crashes of either of those are propagated, or crash information is propagated to the system so that we can restart these entities. So that needs to be fleshed out, how we actually tie that into the clients of, the clients communicated with those services. And the other thing is the IPC logger, which is the downstream name for a mechanism to just log and track what's going on in the system. There is two parts there. One is the tracing bit of keeping track of events. I think the trace framework and trace points should be used there instead. And but there is quite a bit of work to figure out all those places and make sure we have the trace events that matches what Qualcomm would need to debug certain things. The one that's more interesting for us, go ahead. You have a.
So for the IPC logger, are you thinking of using that? I don't know exactly how it's work, but moving all the ftrace event right now instead of using this round robin internal RAM, moving that in this logger to get that outside without any, impact on performance overhead? Is it possible? Something possible?
So downstream, they don't use the trace frameworks that we have,
Okay.
and I think we should, rather than invent something new. I think the bigger question that's left there is Qualcomm uses this quite extensively for post-mortem debugging as well. So when they hit some issue, they dump the memory, and they can look at the IPC logger buffers to conclude what the system was doing when things happened. So it might be that we need to look a little bit at how to do post-mortem debugging of the trace events, but it's not the highest.
Yes, please convert this to ftrace. As the guy who wrote it.
Thanks.
It's primarily post-mortem debug. It was originally intended for what was at the time the SMD, and then everything converting over. Those interprocessor communication frameworks have a lot of state in them, so a memory dump like a K-dump at the time tells you what failed, but there are many state transitions that can get you there which are relevant to the actual fix, which is where this was implemented. Also at the time, ftrace was not enabled in the builds, and we really had wanted this for customer use. Basically, customer reports an issue in the field, we need to figure out what's going on. But yeah, I think ftrace has evolved since then to the point where ftrace is the more appropriate mechanism.
Just for my understanding, is this purely a software feature, or do you write to some hardware buffer that then does something else?
Unless something has changed in the past 2 years since I last touched this from moving projects, this is completely software. It basically allocates several pages of memory, DDR, and writes. In fact, it just writes text to it for simplicity of parsing.
So there's a patch that has been posted recently. I don't think it's merged yet, but it likely will be, for tracing MMIOs and writing the trace of those MMIOs into persistent storage. And we might be able to do the same more generally by writing ftrace events into the same persistent storage for the purpose of postmortem analysis. That would be a generally very useful feature, and it could just replace what you have here and help a lot of other people too.
Yeah, that sounds reasonable, even if persistent storage would be some statically allocated chunk of RAM. Exactly. But that would be quite convenient.
Case, but it could be anything.
The other part of the IPC logger is when seems to be helping when you're actually introspecting what kind of data was flowing in these shared memory communication channels. And for that, I really would like to see something like USB mon, or where we can get the data out, dump the data out to user space in and get it in some sort of like a PCAP format or something, so we can use existing tools for dissecting the communication streams. That would have been. There is several times already where we have found that would have been really helpful to have. So that's higher on the to-do list than the event or the tracing. So memory, Srini? You have a microphone there.
From the SMMU side, I think there are some pending patches, runtime PM patches, which are still under discussion. That's still not merged yet. I think it's V17 or V18 at the moment. I'm not sure about SDM845 TLB stuff.
Do you know if that errata that has been discussed back and forth is required for us to do anything, or?
No. You mean the cache stuff? I've not looked at estimate
Okay.
for
There is a patch that has been going back and forth on the main list for a while.
Yeah.
To get some errata for 845 in.
No,
but I
I've not
haven't.
looked at it.
I haven't paid that much attention to that series. Yeah, and the fast map stuff, that's just performance enhancement. I don't know what the progress are on the other two items. But I think work has started on the fast map stuff at least. Amit?
Where's Nicholas? Okay. So you want to get the first one, Nicholas?
You start.
All right. Okay, so the OSM CPU FREC driver for 845, it's already in revision 8. There's now some feedback. It's mostly around the DT bindings, really, at this point. I think we've been going for the last couple of revisions. It's mostly been about getting the DT bindings right for that. This is also related to the DevFreak patch that Sarvana you've sent. I think it's going to end up being a common looking set of DT bindings and common way of actually addressing them. But other than that, the overall driver seems to be okay. One question though is, where are these being tested? Because are these being tested on a backported kernel for posting?
You're talking about which one, the CPU Freak or OSM? Yeah, so the OSM for CPU Freak and DevFreak stuff, we can just test it on any kernel because the interface of the kernel hasn't changed. So we just put those patches on whatever kernel we have and test it out, because we have the rest of the system to figure out it's working. At least that's what I'm doing for the DevFreak part.
So I'm gonna, yeah, so 414, it doesn't work on mainline. So I have posted a comment there, and we need to get this all into the integration tree to get it being tested against mainline.
So okay, maybe I'll speak for just myself then. I'm talking about the DevFreak stuff. If you're talking about the OSM CPU Freak that's not working, okay. I believe they have been testing it on 414, maybe they're not, so I can double check on that part.
So I'm just going to dump these patches into the integration tree, and so we start testing them against mainline. On the, let's see what else I've been working on. So cluster idling, I'm currently in the process of reviewing Wolf's patch set and providing a A20C implementation for those. So then we will have one more platform supporting cluster idle. Nicholas, it's all you now.
For 820, we also have the clock driver, which is missing, which Ilya sent, but then he went on to other opportunities. So we probably need to take ownership of that and finish that up as well. And then I've been working with Viresh. There is some bugs with the OPP stuff that's probably gonna get merged this next merge window. And there's device tree stuff missing for 820, like I said. But we're thinking of reworking because right now we have the regulator in the CPU device tree node, but I'm in the process of reworking that and using performance states with power domains, set performance states. So I'm working on for Dragon Board 410 to start with, but after that I will continue with 820, and then we will replace the regulator P handle in the CPU node with the power domain. So it will be it will be the power domain driver which also registers with CPU FREC, so that will eventually change for 820 as well.
Yeah, the use of a direct regulator from the CPU node seems to work on some devices, and others it's not. So yeah, that got to be production differences, and that difference is taken care of by the CPR hardware. So once we have a driver for that, we should be able to tie in the entire DVFS component upstream as well.
The downstream solution is quite different, where they have implemented. They've misused the regulator a bit, and yeah.
For the clock driver?
Bruni doesn't really like how it's done, so. But I think that the performance states is really. It's a really nice solution, because you just set the corner, and so you only get an integer, and that matches with how it's implemented in the hardware. To just set the corner, and so you don't need to know the specific voltages. And
so now we have when we have the support from the code that came from Viresh and others. I think we have all the plumbing pieces in there, but we need. In particular, the CPR driver and the power domain driver from Regendra, and that is the state of the power domain driver is that the code looks good. There was a question from Rob regarding the binding, where we essentially had an OPP table to find that it's essentially mapping 1 to 1 and 2 to 2 and 3 to 3 to define the various levels of performance state we can have. So there was a little bit of discussion. So hopefully we can finish that up and come to an agreement on how to get that settled.
Can I just wanted to add some more on the DevFreak stuff? So the DevFreak driver for this one for L3 that it's just a standalone driver. We can finish it up. Need some DT review and whatnot. For the DDR scaling, it's still going to be dependent on the interconnect framework going in. So hopefully, Georgia can get that in, and then we can get the DDR scaling in. And lastly, for the governor to then scale the cache in DDR based on CPU frequency, that needs more work with the DevFreak maintainer. So that seems to be going slower than I would like to. But that's where it's going.
Georgie, you want to talk about the interconnect framework?
Yeah, so the interconnect patch set has been for quite a while on the mailing list, so now it's version 9. It has been reviewed by various people until now, so the main blocker for merging was the device tree bindings. So there is currently, I think, an agreement. So the binding hasn't changed for the last half a year, the proposal for that. So I'm targeting the next merge window to merge this. Now it's in Linux Next as well. The patch set contains support for the on-chip interconnect API, which includes driver for MSM 8916. There is also a driver for 8996, and someone from Qualcomm is working on SDM 845 driver. Feature-wise, we are currently testing support for the active and sleep sets, which we have implemented with some path tagging. This needs some further testing. And the next task is to polish a bit the integration of the various subsystems and drivers with this framework, so that all the consumer drivers can report their bandwidth needs and the hardware is scaled accordingly to the needed power profile. I have posted today some example, and we'll continue with examples with other subsystems. Some of them might require some more work, some are complicated, like the display controller driver and others, but I think, yeah, we can do this.
So it would be nice if some of the kernel maintainers, maybe from KWG, could look at the code and help get this merged, because there's lots of other stuff that is gated on this. I mean, fundamentally the code hasn't changed in the last, I don't know, 3 revisions now.
No,
So,
it's been fairly stable now.
Yeah.
And yeah, so what I think we need to do to finish this up is to do some proper reviewing of it and actually have some people state that it's good, and also provide a couple of the client drivers to show that there is actually consumers of this interface. And I think the only discussion point we have left is how to signal the sleep set, active set information on a per client or per path base, or maybe per client basis. So that we need to settle, and then with that we should be able to send it out.
Yes,
or
so
to get it merged.
yeah, so the main blocker for this was actually that there was a lack of interest from other vendors. So and maintainers want, when you have a binding, this binding should work not only for you but for other systems and architectures. So
yeah, but as the binding so the binding we have today, it
Yes.
describes paths.
Yes, yes.
A lot of the continued discussions around the framework is how do you describe like use case paths, use case based bandwidth tables. So like something like, do you use OPP, or do we calculate the bandwidth out of what we know in the drivers? And so far when we're trying to come up with a case that we can use to discuss what would be a suitable solution for this, we keep coming back to that we either have hard-coded needs, because the hardware will always produce data or use data at a certain rate, or we can derive it from, say, baud rate or clock rates of the external buses or something. So, or like in the multimedia cases, it looks like that we can derive this from resolutions or the media content, and the question is, will that be good enough, or do we need headroom, or do we need this to be actually configurable? But we need to find a concrete example of where we really need to be able to describe this and see what is the selector of the state, or what information do we need, and is it do we need the bandwidth for certain paths, or do we need it for all paths, or yeah. So I think we're getting to the point where we should be able to get the part where we describe paths in and start to solve all the simple cases upstream, and then hopefully find a case that is more complex and requires more.
Have you been able to talk to anybody from NVIDIA? Is there anybody left at NVIDIA? Because I think they have very similar requirements, and I don't think there's anybody else that has this, but it, yeah.
So not from NVIDIA, but I have ongoing discussions. The IMX7 architecture is using something similar, so it fits exactly into this concept. So they will be the next user of that. I have looked into other vendor kernels and found similar. I think Rockchip, and also now there was a discussion on the mailing list with Maxim on the Allwinner, some DMA stuff, which finally will use the same interconnect bindings that was proposed. So this as well, and yeah, there was also some other conference in the OSPM summit. It was discussed there, and actually this concept will even work for Intel architectures. This interconnect API can provide information to some firmware, and yeah, so this can actually work for everyone.
Yes, I think that we have interest enough from enough other vendors to continue with what we have, and once it's there, we have something for others to actually work on top of.
Right, but if at least the Rockchips and Allwinner people have had a look into this and say this looks good to them, that gives me much more confidence.
Yep.
For the OPP, I kind of talked to Viresh about it to see if we can have bandwidth OPPs. He seems open to it. The only thing is try to see if what the DT format is going to be. And I believe somebody from Qualcomm has already sent out a patch for this. I need to take a look at that part. And the use case wise, CPU was the one case where we definitely need a list of OPPs to pick. And we can tie the paths OPP to the CPU's OPP. There's apparently already support for that, called recommended OPP. So for each CPU OPP, you can have a recommended OPP for some other device. So that's the plan. I'll try to use it for mapping.
Okay, good. Yeah, the one major thing left in the power, well, after ULF enables all these kind of bugs that we will find when we actually try to go low power. But the feature we need is being able to specify the regulator levels for when the CPU goes into to idle or when the CPU's power collapse. Because right now we can only set the actual value for regulator, and it won't switch as part of power collapse. So that's still open how we describe that in the framework and how we interface that. The sleep set thing, we have talked to you for like 4 years now, but not have given you any patches.
Right, yeah, I didn't think it was a clarity problem. I thought it was a writing code problem.
Correct. Yeah.
Right, okay, yeah.
The ball is in our court.
Yeah,
to provide you with some
that's okay, yeah, it sounded like it was a clarity problem, but yeah, I thought we'd nailed that.
What's OCI there? Previous slide, what's OCI? Okay. He said it's on-chip interconnect.
Good. Amit, do you want to talk about thermal?
So we got decent support for SDM845 upstream in 4.18. And then I've done a bunch of cleanup to consolidate the driver, so we can actually support old and new versions of the tsense IP in a common set of functions. After the next merge window, there's enough cleanup in there that I can drop IRQ support for tsense in on top of that. And then I'm working on something for low temperature governor and limits hardware. That's a very Qualcomm specific thing. On the still to do list, we've already talked about this earlier this week with the power management working group about extending the thermal framework to handle some more complex thermal conditions. I mean, some of these SoCs have a lot of thermal sensors on them, and how we can actually create a hierarchy of these thermal zones. Currently, the thermal framework doesn't support that. This is also scheduled to be discussed at LPC in 6 weeks at the thermal microconf. So if anybody's interested, please contact me or Eduardo Valentin, who's the maintainer for that. Yeah, that's it for the thermal for now.
Yeah, so for peripherals, I think we got both the USB PHYs for 845 sorted out upstream, and I think we actually got the DT. Andy, did you pick up the DT for 845 USB? Yes. Good, so that's done. We have the UFS QMP5 for 845. The patches are reviewed. I don't think they've been picked up. But in order for us to use them, we need to drop a direct function call from the UFS host controller straight into the old PHY driver. So I've talked to Vivek about that, and he was going to prepare a patch for that. So that should give us UFS support for 845 upstream as well. We have UFS support in mainline for the 820 Dragon board, so 8996. We got the 845, they changed the serial engine, so UART, I2C, SPI, and yeah. They got a new set of drivers. The SPI, I think it's been on the list, but I don't know if it's been picked up yet. We got the new, for some reason the register layout was changed in the SDCC controller. We got the patches merged with the register changes. There is some power-related pieces that I believe is still being discussed, where the switching between voltage levels needs to be coordinated with the controller, which causes some issues with how the framework today does that. But there's patches for that. We had the random number generator as we tried to get that supported on the new version of that. We ran into some issues with the maintainer saying that this is not a hardware random generator. So that was moved to, which framework is it now? Huh? Crypto. Okay, so it's a crypto pseudo random generator now. Hope the consumers are happy still. We finally got the PON, the probably power on module in the PMIC reworked, or the drivers for that, so that we can do reboot reason, and we can support reset. We can support having the reset line generate a key event, which means on the Dragon boards we can actually implement the volume down key. So that's all merged, and there's been patches going back and forth on the embedded USB debugger found that we have in 845. But I don't think they have concluded anything there yet. Display, Rob?
So I guess you'd say the basic DPU stuff has landed, and there's been a lot of fixes and patches flying by. It was trimmed down quite considerably from the first patch that posted in, I think it was January or something. So now it uses the same DSI subdriver as the older generations, and I don't know, there's probably, I think it was like some 30,000 lines of code dropped from it. Yeah. Let's see. Yeah. Okay. I guess there's some things to do. There's actually probably a bigger list of things to do than just that, but I mean, there's some fairly elaborate color management and other things that can be supported, but yeah.
But the basic, we have a basic functional display driver upstream.
Yeah. I mean, there's a pile of fixes that I've pulled in for what I'm using right now for like cursor stuff and things like that, but yeah.
Yeah.
And GPU for A600 also just landed for 419. There's at least one patch we actually needed in the DRM driver that's blocked on some ARM SMU changes. Like we can't land that without breaking current, previous generations unless the ARM SMU part is in place. Actually, quite a lot of stuff indirectly ends up depending on ARM SMU. That seems to be the long pole in the schedule, I guess. But yeah. There's a bunch of debugging and robustness things that are still work in progress, but.
So the A6X DCVS supports like a DevFreak driver that you upstreamed, or?
No, so A500 has a DevFreak driver on A6. It's all handled by GMU.
Okay, cool.
And actually, I was just mentioning, I think I need to talk to Georgie about interconnect scaling, because that's also handled by GMU, but we need to give GMU the tables of things to set.
Yeah, okay. That's an ugly hack on the Qualcomm side, but we'll see.
Yeah, Jordan would know better, but we might be able to start by just ignoring that and doing the interconnect scaling in software. But I think at some point we need a way to ask the interconnect framework what are the values you'd program for each of these different settings, so that we can populate a table that we can give to GMU so it can handle this.
Okay.
Yeah.
Do we have the interconnect scaling for A5X? Bandwidth scaling for A5X?
Or 820.
No, sorry. Let me clarify. So you said A6X, you said interconnect scaling is done by the GMU. For the older version of the GPUs, do we have interconnect scaling planned or no?
I think there is for the 820, right? Yeah. So I've seen some, I think we have patches ready to land for the GPU side of things when the interconnect framework lands as well. That might be the easier way to do it, to land them in the same kernel version. Yeah, okay.
Yeah, I think the point I was trying to do was maybe we can do it in software for the older GPU and the newer one, and then we can do the GMU part later.
Right.
That will get something in quickly to scale it.
Yeah, I think that's what we'll do. Oh, and we still need, so dev core dem support for A5X is landed and still missing for A6. Yeah.
And at least the per process page table, that should be ongoing rather than still to do.
I think that's not too hard to do on the driver side, but again, we have to come up with a way that the ARM SMU folks are happy with. It's a little bit challenging for the GPU because it has very different requirements on the IOMMU driver than what the IOMMU driver is designed for.
Video? Back there.
Okay. So the only major difference from last time is this Venus version 4 support for SDM845. So we still have two major things under review. This is the firmware folder without thread zone, and also we need small changes to make the driver compliant with the stream codec API. So yeah, but basically we have support for SDM845 currently in the mainline.
did you make any progress on the video memory on 820?
I have the patch, but I didn't upstream yet because I just want to test some more things before selling.
I said, speaking of the system cache, I think the last time the LLC patches were posted was quite a while ago.
The LLCC?
Yeah.
I'm pretty sure Andy picked those up, so we have the LLCC.
Okay.
But I don't think we have anyone using it, or I don't know if you need to use it to use it.
Yeah, I started trying to pull that into our kind of 418 branch. I'm not sure that it's actually working.
Okay.
So.
So we had earlier this year we did work on the Bluetooth that we have in on the 820 Dragon board and got that working. And during the summer, there has been ongoing work back and forth on trying to get the Bluetooth for 3990 working, and that has now been merged. So we should be functioning pretty good on Bluetooth side. There has been patches posted and being discussed for the MHI bus, which is related to how you do PCIe attached modems. The big ongoing item here is the IP accelerator that Alex is working on. There's been a lot of cleanup. There's been feature reduction to hit a good first set of functionality, and we hope to see a first post of that soon. It's functional in the Chrome environment that we have tested and a Chromium environment that we tested, and now Alex is moving it to mainline with the changes in testing strategy that requires. Audio? Behind you.
Since last connect, I think we made significant progress on DSP-based audio solution on mainline. Currently, we have basic building blocks to do a DSP-based audio, both digital and analog. We have tested it on multiple platforms: STM845, 8996, 8916, 8974, and APQ8064. The next to-do items are in general SoundWire and some of the compressed offload support using dynamic module loading onto the DSP, which uses fast RPC under the hood. So that's still been explored, and hopefully we'll have something before the next connect.
So for the camera subsystem driver, this is the CSI receiver and decoder and the VFE. Now for 8996 we have the same features which we already had for 8916. So these are direct write to memory, and for YOV frames we also have hardware downscale, crop, and format conversion. So, and of course for 96 we have the support for the second VFE. So all these are now in 419.
So did we not get the CCI driver picked up? Okay. Okay, so one more iteration. Yeah, the major thing with the CCI driver is still to figure out how to interact with GPIOs there. It's more or less an I2C, but you can time the I2C operations based on GPIO input or output GPIO signals in that queue to to time things like strobe lights and to match that with the commands that you send to your camera module. So that's both a question of how do you implement that in the driver and how would you expose that to anyone else. So that's still on the to-do list. And it would only be a problem if we do more advanced camera setups than what we have looked at so far. Either this button doesn't work or that was it. Well, one thing that we should mention, we briefly mentioned the fast RPC for loading audio codecs. That's part of a bigger job of enabling the compute offload interface that Qualcomm has, which is the real use for fast RPC, or the main use. So that's there's pretty good progress there, and we should be able to enable what's called the Hexagon SDK, where you can build your own apps and offload computation to the various DSPs. But
there is also Wi-Fi for STM845, and I talked to Kalle Valu, the maintainer, but he says that you've been writing some user space applications to actually be able to load the firmware, but Kalle said the patches looks good, but he wants to actually get the firmware blobs into Linux firmware before he actually merges the kernel patches. So okay. I guess we.
Yeah, then we need to follow up with. I thought he was the one who's going to push those.
Yeah.
Also, what's the state of the firmware blobs going up for the 410? They're not there.
Which ones?
For the Dragon board 410 for the Wi-Fi firmware.
So for the 410 firmware, we got the permission to put them there. The problem we have with the Wi-Fi firmware specifically is we have not yet figured out what that firmware is tied to. So it might be that the firmware is for the 410 platform. It could be that it's some special firmware. It looks more like it's 410, and the firmware looks pretty similar to some other platforms. So it could be that it's related to the version of the ARM core that they have stitched into the SoC, or not ARM core, but the ARM core and its surrounding pieces. So we need to loop back and figure out what should we name the damn firmware file, and that also goes for example, for the ADSP, the audio DSP on 820 that we have permission to disclose the file, but we don't know what to name the file, and we could just run ahead and push them as device specific. The problem is that once we've done this for even the boards we work on, we're going to grow Linux firmware quite a bit. And if we set that trend, we're going to explode Linux firmware with just Qualcomm binaries that looks fairly similar.
Just name it for the MD5 some of the firmware.
Yeah, so we have the GPU firmware in there, for example, because that is shared between. So the version of the GPU defines which firmware it is. So the platforms that share GPU, the version, they can reuse the firmware. But that is a thing we're still looking at. And and on the Wi-Fi and the 410, there is it's improved a lot even since last Connect, stability-wise, but we still have a couple of outstanding bug reports, things that people that report stability issues.
I've noticed it's got a lot better. For me, the firmware is one of the things that people complain to me, like users complain to me regularly about, and so I was just wondering why we were here.
Yep. Anything else? Are we all happy? Good. Thanks.